Hello everyone and welcome back. So I'm starting off with some of the more intermediate topics now. We're going to have a look at something called an ellipsis, and it's treated as an array. And what we know from the previous videos is that when it's treated as an array is an object, and it also an object reference type, and it also knows its own length. So we have here a method called average. It passes back a double. It's a static. As we know from the English language, static means that it doesn't change. So it's not dynamic. The opposite is dynamic. And then we have here a double total, and we pass in 0.0 is going to be assigned to total. So the initial values of total is 0.0. Then we have our enhanced for, which we have numbers, and then they're double D here. So D is then assigned to incrementally to total. So total equals total plus D. And it loops through, and it automatically knows the length because it's the enhanced for. And we don't need to use a counter controlled loop for this. We don't already know the amount that we're going to pass through, so an enhanced for is quite useful in this regard because it's a little bit more flexible. And then it returns total and then divides numbers, the length. So, and because it's an array, it already knows its length. So when we think of average, when we learn about it in school, you count up the number and then you get the total, and then you divide by the amount of numbers. So that's your average. Now in the main, then we have our D1, D2, D3, D4 here, and then they're just assigned different values. So print it out on the screen first. We know from our placeholders that we can change the precision point. We know the default precision for a double is 6. So if I didn't put anything here, it would come up with 6. So if I run that, I can just demonstrate that for you. Oh. So it has an unknown format. So if we have, oh yeah, because I've got a dot in there. So if I just run that as it is, then it shows here we've got 6 as the precision point. So that's where the placeholders come in really handy. So we have just a 0.1 then to put in here, and then our new line. You don't need to put any spaces here because it will put a space within the rest. Spaces within Java aren't interpreted, but within a string like this, when there's 2 inverted commas, then they are. So if I put a space here and press play, you can see then the next line will have a space on it. Yeah, so it doesn't look so good. So this is why it's a little bit tricky to read them then. Or what you can do as well is do this. If you really wanted to be able to read it, and then it's just returning down the end, and there's still no spaces, but it's a little bit easier to read if you wanted to do it that way, if you had like a huge list of stuff. Here we have our system.out, and we call the average method because it's a static method, and within the same class we don't need to use class name.method. It's already there, so it already knows the methods within its own class because it's in the var args test, capital V for the class name. And within that, then it's, if I was to call it from a different class, it will be var args test, and then maybe lowercase v for a new object equals new. It has a default constructor because it's in Java. It already automatically makes it, so when you create the new object, it automatically constructs it. And then unless I made a constructor down here called public var args test, see, same thing, and then put in different parameters within it, but that's from the previous videos. So here we have our average method, and we have our D1, D2, and then there are variable amount of numbers that we can put into the average. That's the best thing about the ellipsis. And it's treated as an array. That's why it's still part of the similar topics. So now if I run that, and then it just shows, oh yeah, I didn't put in D1, D2 and D3, and then D3 and D4, and now it should show, yeah, so that's the average of those, and that's it really. It's pretty straightforward. The next thing we're going to cover is even better because we read in from the command line, and that's outside of the integrated development environment. So even though I have ran it here, or I have written it in here, I compile it within the command line. So I can show you here some of the things. So the args are the args that are here. So when the main is called, it says the length if it's not equal to 3. So if I don't put in 3 different arguments within the command line, then it will bring me up, it will give me this error. So, and then I have else. So it runs this if this is not equal to 3. And I have 4 different local variables within this main method. So because it's called, because these are we did a scope of variables video previously, I'll put that link down below. And because they're declared within the main, then if I was to declare them within a different method, then obviously they'd go away after coming back from that particular method, so they wouldn't have access depending on the methods. But I did a video on that already, so you can have a look at that. So here we have array length, then an array, and we pass in the array length from parsing from the command line. I'll get to why integer is a capital letter later on, but that's also very important. And we have args here, which is going to be the accessing the array, the string array, and that's going to be your first argument, your second argument, and your third argument, which is the 0 index, the first index, and the third index. And that's what we're assigning: the first index, the second index, and the third index to the array length, initial value, and increment, and then looping through the same as previously using a counter, outputting the headings, and then outputting the actual counter, and the accessing each of the indices in the array and outputting that as well. So if I go to my terminal now, and I've gone to my specific folder, so you can do a CD, it's called, and LS is listing your contents within that. CD ... will bring you back to the previous ones, for the previous folder. So I actually need to go back to my source file because I've set it up like that within Eclipse. So I say CD or C, and I can tab as well, and it'll automatically do that. So I first need to compile it. So that's Java C, and then I have init, and then array.java first. That should compile pretty much straight away. And then after I've compiled it, then I just use the Java command, init array, and then I have to pass in 3 different variables. The first one is going to be assigned to the 0 index, the second one to the first index, and the third one to the second index. So if I have 3, 4, 2, let's say, then so value 4, 6, 8, and it multiplies it down here. So if I have 3, 4, and 2, you can see here that it's going to multiply it. So if I take out this, then it will have a different calculation. So at the moment that's correct. So if I just wanted to spit out the values, then I just remove this here, save, and then go back to my terminal. I can go up with to previous commands using the arrows, and then compile it again. Once it's compiled, then 444. So I have my different variables here as well. So you can play around with that. It's quite interesting because each of these then have different, the initial values come in from the parse from this, and then we have our for counter as we're going along as well. So if I save that and go again, so compile and run again, and I have 468, which is the previous answer, which is correct. Okay, so now we're going to do what's known as array manipulation. So I'm glad now we did some of the command line. We also need to also go through a lot of how you step through the code a bit more, which I'll do in the next part of this video, but I need to pause it now and write out another program, and then we'll come back to it in a second. All right, so I'll see you in a minute. Hello again. So I wrote out the program, but I wanted to draw your attention to two more things first in the previous examples that we spoke about. So we've already covered this, but I wanted to remind you the BIMDAS. So brackets, indices, multiplication, division, addition, and subtraction. So when you're calculating these configurations, you do the multiplication takes precedence over addition. So you have to do the multiplication first and then the addition. So if we have our increment, so for instance, I think I put in 4 in the command line. If we just have a look here, so in our increment value, it's the last, so it's 2, and then our increment value is going to be 3, which is our first increment value. Sorry, 4. So and then you multiply by the counter, and then it loops until the end of the array length. So then we have here, so the array length being the number of arguments that are you can see here that it passes through the array length into here, so that's going to be 3. Because the array length is different to accessing the index in the array, but it looks the same in the definition. Also, the other thing that I wanted to draw your attention to is in here, if I was to remove the word static from here, I would get an error saying that you cannot access, you cannot make a static reference to a non-static method, because it's static to static. So we had public static void main, so this is static and this is static, just so you're aware. That's really important. There are certain keywords that we're going to keep coming across, and in the next set of couple of videos we'll address those as we're going along. So now we're going to do the array manipulations. So we have a double array here, and I think we've only done kind of integer arrays, and we just had a look at the string array. So now we're going to do a double array, and our double array is 1.3, 3.3, 0.2, 7.9, and 3.4. And then we have within each of the arrays, because we have array is a reference type object, then we can use different methods within that, which is really exciting, because you can call whatever you want within it in the system itself. So it has here java.util.arrays.parallel-sort, and then you just put in a double array into it, and it does this sending numerical order automatically. So it sorts. The perimeter array is the array to be sorted, so since 1.8, then this is the implementation note here as well, and you can read about that online on the Oracle website. Here then it just prints out the array again from this. Now we have our enhanced for, we have our double array, and then it puts it into the value and it prints it out as well. We don't need the counter control loop for this. It's again using an initializer list and not using the new, but the initializer list has the implicit new within it, so you don't need to use the new keyword. Here we have our int as well, filled int array and of length 10. So we do use a new keyword for this, so it's we're creating a new object of integer array type, and then we're going to fill it with 7. So if we want to use different things here, so arrays dot, and it gives you a whole list of different things that you can use within the IDE. So this is called Intellisense. It's really useful if you don't know off the top of your head, but obviously Google helps if you want to fill the array or use a hash code or a mismatch or that kind of thing as well. So arrays is really useful. Then we call a display array method, and when you hover over it, it shows here it doesn't return anything because it's void type. Array manipulations is the class name dot array. Display array is the method name, and then what parameters it uses in the signature. So if we go down to that, then it's at the end. So we have an integer type array and then a string description, and it prints it out here, and then it iterates through and prints it out as well. And that displays it as the filled array, and that's the name of it. So every time that you call display array, the first parameter needs to be an integer type array, and the second needs to be the string that you're passing through. Then we have two more arrays that we declare. One is an initializer array, 1, 2, 3, 4, 5, 6. And then we have a copy of that array, and we use the length of the first array, int array, to be the same as the length of this new array, but it's empty at the moment. This int array copy is empty at the moment unless we fill it. So we're using something called system.arrayCopy. So we take our int array, and then here we have our position. So you can see here the different parameters that it's the source, destination, and then source position and destination position, and then the length of the array. So we have our position is 0, and again 0, so from where you want to, where in the elements you want to copy it across. And then we have our display array again, which is going to print out the array and the description, and then iterate through the values and print them out on the screen as well. Then we're going to use a boolean. So we have our boolean b is equal to arrays.equals, and then int array, and we compare both of these two, and if it is equal, then it comes up as this or else this. So this is our ternary operator, which we spoke about in a previous video. I'll also have to link that below. And then we have, again, we use the same variable boolean b down here, and we compare the int array with the filled int array, and we put that out on the screen as well. Then we use something called binary search, which we need to address in a whole different topic, because there are certain searches that happen within a computer. So there's binary search, and yeah, there's different searches, and there's also different algorithms that need to be looked at as well within another video. But for now, we're just going to concentrate on this. So we have our binary search, we have our int location is greater than or equal to 0, and then it prints out this, otherwise it prints out that. So it prints out the element, and that's important because we said that each element in the array is accessible via the index. So if I print that out then on the screen, you can see here it firstly calls the parallel sort. So it sorts it, prints out the filled int array, then the initializer list, which is 1, 2, 3, 4, 5, 6, then it copies it, prints out whether they're equal or not based on the arrays.equals, then prints out if it's int array or filled int array are equal, and it's not, and then it prints out finally whether it found 5 at element 4. So if I go 0, 1, 2, 3, 4, and it's after finding it at element 4. So that is it for today. I will put these up on GitHub as usual, and I will also link some of the other related videos down below. Thanks for watching. If you have any feedback, please send it to learncomputerswithali@gmail.com, and I look forward to posting the new video soon. Thanks for watching. Bye.